Hi everyone, welcome to this other session. We are still doing more examples on a three-phase system. We take this example, a 415 three-phase, 4-wire, star-connected system supplies 3 resistive loads as shown below. Determine the current in each line. Then the second part, the current in the neutral conductor. So basically what they want us to get, we have to get the current flowing in the red phase. We need to get the current flowing in the yellow phase. We also need to determine the current flowing in the blue line. So one interesting thing that you need to note is we have been given the energy or the power that has been taken by each resistor or by each phase. So our duty will be, we need to get the phase voltage. We need to get the specific voltage that was passing through each phase. And remember, before we have done the relationship between the two, it will be very easy for us because we know the relationship between the two. So basically the starting point is you need to get the phase voltage. The phase voltage, remember we have said phase voltage VPH is given by VL, which is the line voltage, divided by root 3. Remember we said this is the same as line voltage. That is the same as the line voltage. So in this case, it means that our line voltage is 415 divided by root 3. If you divide by root 3, you will roughly get 240 volts. I know you will get something like 239.9, but roughly if you round off, you will get 240 volts. That is what you will determine, you will get as the voltage. After you have done that, you also need to know this formula that power is equals to current times voltage. So meaning, because we are interested in current, then it means the current passing through the red phase will be given by the phase voltage. Because this system is balanced, it means the voltage across each phase is the same. Because it is a balanced system, then it means each phase was receiving 240. So the red phase, meaning VR, will be equal to divide by it means the current IR will be equal to the power divided by the voltage VR. So the power across the red phase is given by 24 kilo, which is 24,000, divided by the voltage across that point is 240. So if you divide this divided by that, you will get 100 amperes. So the current passing through the red phase is 100. So the second step now we will move to is to get the current across the yellow phase. The current across the yellow phase will be equal to, remember we have said the voltage is the same. So we'll be having Vy divided by, we'll be having power divided by Vy. We'll be taking the power across the yellow phase divided by the voltage. This will give you, remember the power here is 18 kilowatts, which gives us 18,000, divided by the voltage we have said is the same, which is 240 volts. So if you divide that, you will get 75 amperes. You will get 75 amperes if you use your calculator. The next step is to get the current across this one. Remember, we have said this is our red, this is our yellow, and this is our blue. So the current that is coming to the blue phase, we are using this power. So it means our IB will be equal to power divided by, remember this is PY, this now becomes the power across the blue phase divided by VB. The power across this is 12 kilowatts, which becomes 12,000. This becomes 12,000 divided by the voltage across the blue phase is the same, 240 volts. So if you divide that, you are expected to get 50 amperes. You will get 50 amperes. So we have determined the first case. So we have answered our first part, which was A, where we were supposed to get the current in each line. So the current in the red phase is 100. The current in the yellow phase is 75 amperes. The current in the blue phase is 50 amperes. So the second case is to get the current in the neutral conductor. When you ask to get the current in the neutral conductor, this one, it means we will have to get the horizontal components of these currents and the vertical components of the three currents. So the steps are very simple. So we are looking at part B. And I've said what we will do, we will consider the horizontal and the vertical components of all these lines. So we will start our part B. We begin our part B. Let me erase this. So how do you determine the horizontal component? Remember, if I draw a triangle like this is the hypotenuse, and this is the opposite, and this is the adjacent. Remember, if your angle is at this particular point, this one will be called the horizontal, and this is the vertical. And there is that case whereby if you want to get the vertical, you use sine. If you want to get the horizontal, then you will have to use cos. So you have to bear that in mind as you do, as you resolve the three currents into horizontal and the vertical component. So we want to get horizontal components. Horizontal. And before we go to the horizontal component, another very important point I would want us to know is we need to draw these currents. If you draw the way we have done them, this was our red phase. Let me say these are my IR, which is 100 amperes. I can also have, remember we draw them like this. This is IY and this is IB. Remember, this now becomes our neutral, our IN. So this angle between the neutral and the red phase is 90 degrees. The angle between the neutral and the blue phase is what? What will be the angle? Remember these three angles are displaced 120 degrees. That is the first thing that you need to note. That between this and this is 120, this another 120, this another 120. Because the three currents are displaced 120 degrees apart. We have said that in our previous classes. So the angle between this and this, we know it is 120 degrees. But because we are starting from the neutral, it will be 90 plus 120. So 90 plus 120 will get 210 degrees. Again, with reference to the yellow phase, we will begin from the neutral, going all the way to this particular point. Remember, this this 120, this another 120, which is 240. 240 plus this 90, you will get 330 degrees. So those angles are very important because they are going to assist us to resolve these currents into horizontal components and the vertical components. So now when we are dealing with horizontal components, horizontal components, in horizontal components I've said we use cos. So meaning we will have this I is with this angle which is 90, so we will take 100 degrees, or let me just write this. It is IR cos 90 degrees plus IB will be, IB is cos 210 degrees plus IY 330 degrees. We can now replace such that we can now take the horizontal components and check what we are getting. So we having IR is 100 cos 90 plus our IB is remember our IB was gotten as our IB was 50. Our IB was 50 cos 210 plus this other one was 75 cos 330 degrees. So if you move on, you will be expected to generate values of this kind. So 75 is 330 and that one. So in this case, you are expected to get 21. If you add that and the other one, you will be able to get 21.65. This is now the horizontal component. After that, we can now move to the vertical component. Vertical component. What do you get in vertical component? We just substitute, because we have said in vertical component you use sine, so it will be I R sine 90 plus I B sine 210 plus IY sine 330, which will be equal to, remember we have said this one becomes 100 sine 90 plus we have 50 sine 210 plus 75 sine 330. So if you simplify that, you will be able to get, you will be able to get something like 37.5. That is what you will be able to get, 37.5. After you are done with this, remember, this one now becomes our horizontal component, this becomes our vertical component. Having done that, you now need to put it in a triangle. You can now draw a triangle of this kind. And we say we're having our horizontal component which is 21.65. We're having a vertical component which is 37.5. So remember, our intention is to get IN. because In is the phasor sum of the horizontal component against the horizontal component and the vertical component. So we can use Pythagoras theorem, whereby we can say In will be equal to 37.5 squared plus 21.65 squared under root. If you divide this, if you take the sum of that, you will now be able to get 43.3 amperes. And having with those very few remarks, we are going to stop there because we have now completed getting the current in the neutral conductor. So that is the procedure of getting the current in the neutral conductor. You need to resolve your currents into horizontal and vertical components. Later on, you need to use this triangle to get the resultant current in the neutral wire. So we're going to stop there. Thank you.